It is a pleasure to welcome you to the pitch sharing session of the third edition of the lecture series on advancements in geotechnical engineering, from research to practice. At the pitch sharing session we asked the participants to explain their research with 3 slides and within 5 minutes. They were judged by a 4-member judging panel and the audience members. The pitches that were adjudged as top 3 by the judges and audience members are being shared. The following presentation was ranked 3rd by the judging panel and the audience members.
So, hello everyone, my name is Aoxi Zhang. It is my pleasure to give this pitch. So, the geotechnical engineers use MICP and EICP to improve the strength of the soil. And the magnitude of the improvement is related to the mass content of the precipitated carbonate. So, in this figure, I include a set of data to show the relationship between the carbonate content and the strength improvement, which is indicated by the unconfined compression strength. So from this figure, we can see that in general, the more carbonate content we have, the higher strength improvement we can achieve. But this is not always the case, as we can also observe that in some of the cases, there is a large variation in the strength improvement, even with the same carbonate content. And this large variation leads to challenges in predicting the mechanical behavior of biocemented soils. So why there is such large variation? Let's go inside to have a look at the microstructure of biocemented sands to say whether we can find some useful information. So from the experimental studies, we can basically find 4 typical microstructures in terms of the carbonate distribution. As the first picture shows, the carbonate particles can locate at the sand-sand contact point. We can call this type contact cementing. And the carbonate particles can locate at the gap between sand grains, forming like a bridge. So let's call this type of bridging. In addition, the carbonate particles can attach to the surface of one sand grains. We can call this type of coating. And the carbonate particles can just fall in the void space of the soil. So we can call this type of profiling. So let's come back to the question, why does the strength improvement vary even with the same carbonate content? We think it could be related to the microstructures. To figure out such a problem, I made the conceptualizations based on the SEM evidences. And then I modeled each type of the microstructure using discrete element method with some idealization. After that, I carried out the triaxial compression simulations using the numerical samples. So for each of the cemented samples, it contains only one type of microstructure. So this figure shows typical stress-strain relationship and the volumetric response. So from the results, we can see that the carbonate distribution can strongly affect the mechanical behavior of biocemented sands. Specifically, the bridging type leads to the highest peak strength at a low strain level, and it also shows the largest dilatancy. And the contact cementing type provides a higher strength improvement at the largest strains. But for the coating and the profiling, they can hardly contribute to the strength improvement as they behave mostly the same as the uncemented sand. So from this study helps us understand the role of the microstructure and gives us support for improving the prediction ability and the mechanical performance of biocemented soils. Thank you.